Welcome to the online lecture series on power electronics. Our today's topic is rectifier design with capacitor as a filter. Uh, Before moving towards the detail of the rectifier design and the capacitor design or its selection, we will review the full wave rectifier. So what kind of waveform do we get in case of a full wave rectifier? In case of a full wave rectifier, the circuit we will be using is this, in which we are using 4 diodes. The input, if the input signal is like this, that is a sinusoidal signal, the output obtained will be like this, in which both the positive half and the negative half of the cycle are being rectified and a DC output is obtained. But if you see, this is not pure DC, this is pulsating DC. To operate the DC loads, we need a nearly constant DC voltage, but this kind of waveform is not acceptable for our circuits or for operating our loads. So that's why we need filtering. If the positive polarity comes, in that case D1 and D2 will be operating and this path will be followed. And only this part of the waveform will be reflected at the output, which is this. And when the polarity will be reversed of this sinusoidal source, this diode D4 and D3 will be operating, and the output voltage obtained in that case will be this one. If we see, if the frequency of the input signal was f, so the output frequency is 2f, which means the frequency of the output waveform is twice as that of input frequency. Suppose that you are asked to design a rectifier whose specifications are its output power is 5 kilowatt, voltage is 1 kilovolt, and allowed ripple is plus minus 1%. And the average output, or we know that average and DC are the same. So basically we are talking about the DC current that we are going to obtain at the output is 5 ampere. Our load is 5 ampere and output voltage is 1 kilovolt. So the end user, he has given you these specifications that he want to drive a load of such power rating and of such voltage, and its allowed voltage ripple is plus minus 1%, and its output, the output current or the load current he wants to drive or use for some load is 5 ampere. So you are only given with these specifications. So how are we going to use these specifications for our purpose, or how we are going to design him rectifier, select a rectifier and design its filter. So the design considerations will be on the basis of the specifications that he has, the end user has given me already over here. In that case, the first thing that I need to consider is the selection of a filter. That is, whether depending upon the type of load, either an inductive capacitor is suited, a capacitive filtering is suited, or a combination of LC filter is suited. So based on the type of load he has given me, I will consider that whether I am using an inductive or capacitive or a combination of these two. Then another thing that we need to consider is the specification of diodes. On the basis of we will start designing our circuit from the load side, and from the load side will move towards the source side. So in that case, in the specification of diodes, we will consider the peak inverse voltage of these diodes, its peak value of the current, RMS value of this current, and the average value, and the other parameters that we have previously discussed. Also, we need to consider the fact that either we are given with the input transformer or not. If we are given with an input transformer, in that case we will have to design the transformer as well. That is the peak value of the current, the voltage, the RMS. Basically, we define the transformer in terms of its VRMS and IRMS. So those will be the our key factors in deciding the size of the transformer. So basically, we have to decide its kVA rating based on its IRMS and VRMS. And optionally, there could be an input filter, but we are talking about the we will be only talking about the output filters in today's case. We are given with a scenario like this, in which we have this transformer over here, then the full bridge rectifier, this part, and this capacitor is we are considering that we need a capacitive type of filter for this application. So we will be discussing about the capacitive filter design in today's lecture. And this is our load. The load current, the specifications of the load current are 5 ampere, and the load was supposed to be operating at 1000 volt, and we are given with this ripple of plus minus 1%. 1% of this 1000 volt will be 10 volt, which means that our output voltage will be like this. If this is 1000 and this is 1010 and this is 990, so my output will be somewhere between these two boundary conditions. The maximum my voltage can rise up to 1010 volt, and the minimum that I can obtain at output side will be 990 volt. If I suppose that in case this ripple is being added in the output of 1000 volt, the maximum voltage that I will obtain at load end will be 1010 volt. Since this is in parallel with this capacitor, which means the same voltage is being appeared over this node, and now again this is in parallel to these two branches D3, D2 and D1 and D2. So 1000 volt 1010 volt will appear at this point and at this point as well. Since only one of these diodes will be operating from this branch, either D3 will be operating or D2 will be operating, and similarly from this branch either only D1 will be operating or D4 will be operating at the same time. At a given instant time instant, only either D1 will be operating or D4, and from this branch either D3 will be operating or D2. D1 and D4 cannot operate at the same time, and similarly D3 and D2 will not be operating at the same time, which means whatever the value of the voltage that is appearing over this node or this node will appear across only one of the diode. So the peak inverse value of the diode will be 1010 volts. In case if both of these diodes were operating, in that case we could have considered that the peak inverse voltage of one diode is 1000 volt by 2. Now the same voltage is being supplied from this input side, that is a transformer, but since we defined our transformer in terms of its RMS value, therefore whatever the peak voltage that I am obtaining at the output side, it is the same on these nodes, this node and this node. So which means that this is the voltage is being supplied from the this transformer side Vs. So the peak divided by under root 2 will be given will